We do it thousands of times a day without a second thought. We step, we walk, we run, relying on the extremities down at ground level to manage the impact of every stride. Toes are often dismissed as the blunt, inactive ends of our feet, minor anatomical details that carry little functional weight. But the physical reality is intense. With every step, jump, and sudden shift in balance, we send a massive wave of kinetic energy straight down into our feet, applying punishing loads to those tiny bones. This mechanical system provides the forward leverage required to stabilize your center of mass. Without it, your base of support shrinks, and your foundation lacks the surface area to catch your weight as you move forward. To understand how this works, we have to look at the foot as an intricate weight-bearing machine, one built out of organic levers, pulleys, and natural shock absorbers. The primary powerhouse of this entire system is the big toe, scientifically known as the hallux. During push-off, the hallux absorbs up to 40% of the kinetic force. The second and third toes act as primary stabilizers, evenly distributing weight. Finally, the outer pinky toes serve as lateral kickstands, bracing against the ground to prevent rolling outward during quick turns. Human mobility relies on this perfectly harmonized division of labor across these 5 distinct mechanical units. Precision engineering is fragile. When you subject a finely tuned machine to constant, unnatural stress day after day, the mechanics start to fail. This skeletal model shows the formation of a bunion. Constant pressure from narrow footwear physically forces the big toe inward, which eventually misaligns the joint at the base and creates a painful bony protrusion. That same external pressure causes ingrown toenails. When narrow shoes squeeze the digits together, nail edges are forced downward, piercing directly into the surrounding soft tissue. Not all failures are structural. Some are electrical, like waking up in the middle of the night with an excruciating toe cramp. That sudden, involuntary curling is an electrical misfire in your nervous system. It's typically triggered by poor circulation, dehydration, or a lack of key chemical fuels like magnesium and potassium in your bloodstream. Our daily habits, from the shoes we choose to the way we stand, can systematically dismantle the very machinery we rely on to move. A compromised foot destabilizes the entire skeletal stack. When the toes stop distributing weight correctly, the ankle must tilt to compensate, sending a ripple of misalignment upward through the knees, hips, and lower back. The most effective way to repair this system is to eliminate external stress. The first step is switching to footwear built with a wide toe box. This diagram illustrates a mechanical concept called toe splay. On the left, digits are trapped in a narrow shoe. On the right, the toes are given room to expand outward. They need this wide physical footprint to properly grip the ground and absorb force. The second maintenance protocol focuses on the internal hardware. You can counteract muscle tension and improve local circulation by performing targeted, daily toe stretching exercises. Finally, you can prevent structural tissue damage by changing how you groom. Trimming your toenails straight across maintains safe boundaries and keeps the edges from digging into your skin. By respecting the biomechanical engineering of our toes and giving them the physical space they need to operate, we secure a strong, pain-free foundation for lifelong mobility.